right, our objective for lesson 6 is going to be students will be able to use the area model and number line to represent mixed numbers. And if you think back to fractions, mixed numbers were numbers that had a fraction and a whole with units of ones, tenths, and hundredths. So we kind of learned about tenths mainly last week, and we've learned about hundredths yesterday and today. And now we're going to incorporate ones, and you guys already know ones. That's something you've known for a long time. So we're going to incorporate them in fraction and in decimal form. So right away, we have these two models, and these two models are cut into different types of pieces. This model is called cut up into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 pieces, so we would call this a tenths model. And here, if I were to count all these little pieces, I would have 100 pieces. So these are hundredths. Now, I'm going to think, together, what does this model represent? Well, there are 10 tenths, so I know it would be 0.2 because this is the tenths place. And let's see how many hundredths there is. There is 1, 2, oops, sorry. There are not 10 tenths. There are 10 tenths. 10 tenths is 1 whole, not 2 tenths. 10 tenths is 1 whole. There's 1 whole model colored. And now when we move on to the hundredths, there are 22 hundredths. Now, because there are 22 hundredths, we know we have tenths in here. Remember, to make 1 tenth, you need to bundle 10 hundredths. There is 1 bundle of 10 hundredths, 2 bundles of 10 hundredths. So there is 1 whole, 2 tenths. So that's in the tenths place. Now we got the 2, there we go. And there are 2 left over. And that will be in the hundredths place. Now, Miss Leon, if these are all hundredths, why is the first 2 in the tenths place? Well, that is because you bundled these, and these moved up 1 place value to go from hundredths to tenths. See how one of these rows is the same as one of these rows? Well, we have 2 total. So that's 1 tenth, 2 tenths, and then you had the 2 hundredths left. So together, these represent 1.22. So let's look at it here. There is 1 whole plus 22 hundredths. When we say there are 22 hundredths in this model, we are saying there are 22 shaded out of 100. So think of this line as it's saying out of 100. So shaded would be the top, total would be the bottom. When we have a number like this, 22 over 100 is the same as 0.22. Sorry, is the same as 0.22. And you had 1 whole, which is the same as 1. Therefore, 1 and 22 over 100 is the same as 1.22. So now all you've done is you've mixed wholes by having them shaded like this one. So now you don't only have hundredths or tenths. Now we're mixing wholes, hundredths, and tenths. Now, how would we represent 1.22 on a number line? Well, I know that it's going to be more than 0, and 1.22 is going to be more than 1. So I know I'm going to be focusing here. But let's show my jump of thought by first representing the whole. I'm going to represent that whole until I get to the 1 right here. Sorry, kind of hard to see through the camera. So plus 1 whole. So I just made the jump from the ones. Now I'm going to make the jump from the tenths. I made the jump from the ones, check. I'm going to make the jumps for the tenths. And 2 tenths So because I know that there are 10 lines in between each number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I know that 0.2 or 2/10 will be me jumping 2 times. So 1, 2. So this is point plus 0.2. Now 0.02 is tiny little fractions in here. So then I would make one more tiny jump around there, plus 0.02. So in your problem set, when you have to do representations on a number line, I want you to show me the jump for the whole first, then the jump for the 10th, then finally the tiny jump that you'll make for the 100th. And how does all of this make sense in a place value chart? So think back. Remember, if I have 10 hundredths, I can make 1/10. If I have 10 tenths, I can make 1 1. If I have 10 ones, I can make 1 10. And if I have 10 tens, I can make 100. So the pattern continues across. So 10 hundredths equals to 1/10. So think about it as pennies. If I have 10 pennies, it's the same as 1 10-cent coin, which is called a dime. And if I have 10 dimes, I have the same thing that is called a dollar. And if I have a $10, it's the same as having a $10 bill. And if I have 10 $10 bills, it's the same as having $100 bill. So notice how this pattern does not change across. We go from bundling in tens, bundling in tens, bundling in tens, bundling in tens, bundling in tens. And here is where you arrive at a whole. And anything behind here, you will know is actually a fraction. Because if you think about it, a tenth is really 1 out of 10 of a dollar. And a hundredth is only 1 out of 100 of a dollar. So when you are representing in your problem set numbers like 6 1 and 20 hundredths, think about it. Say you have 6 wholes. So I'm going to put the 6 in the ones, and you have 20 hundredths. Technically, we don't have any tenths because they're just telling us we have hundredths. So I'm going to leave the tenths blank, but it would be wrong to put a 20 there. And you know that because you know that you should never have more than 9 in here. You can rebundle. And if you have 20, you can make 2 bundles of tenths. So this would move over here. This friend would turn into 0. Therefore, 6 ones and 20 hundredths would be the same as, and remember, what's that super important thing that's between the 1 and the tenths? That big decimal point. So the 6 ones and 20 hundredths would be the same as 6.2, or 6 and 2/10, or 6 and 20 hundredths. And remember, all of these will equal to each other. This is equal to this, and this is equal to this. All right. Also, in the problem set today, I kind of wrote in the questions on formative instead of posting the whole problem set. We'll see if that makes it easier. It does take a little bit more time to do, but if that makes it easier, we'll keep it that way. Just let me know during office hours at the end of the day how you feel about it.